Welcome students to another class on differentiation. Let us revise first principles. We know f dash of x, this is limit f of x plus h minus f of x upon h as h approaches 0. Whenever we find a derivative using this limit, we say it's differentiation using first principles. So this is the first one. F of x is sine square of x. We find out f of x plus h. This is sine square of x plus h. Then we substitute values. F dash of x is limit of this minus this. Sine square of x plus h minus sine square of x upon h as h approaches 0. Now, what is sine square a minus sine square b? Sine square a minus sine square b. This is sine a plus b into sine of a minus b. This is sine of a plus b into sine of a minus b. X plus h minus x, this will be sine of h upon h as h approaches 0. Now we know this limit of sine of theta upon theta as theta approaches 0 is 1. Therefore, this is sine of 2x. So derivative of sine square of x is sine of 2x. The next one, f of x, it's x into e raised power x. We can find out f of x plus h. This is x plus h into e raised power x plus h. Substituting these values in the formula for derivative, its limit of now this minus this. This is x into e raised power x plus h into e raised power x plus h minus f of x upon h as h approaches 0. We combine these two terms and take x into e raised power x common. So inside we'll have e raised power h and minus 1 from this. Plus this is h into e raised power x plus h divided by h. This also divided by h. Limit of this whole as h approaches 0. This limit is 1. So this will be x into e raised power x. Here h cancels out. E raised power x plus 0. This is e raised power x. So e raised power x into this is x and plus 1. The next one, we have f of x equals to x square into cos of x. We find out f of x plus h, which is x plus h whole square into cos of x plus h. Then substitute these values in the formula for derivative. This formula, limit of f of x plus h. This can be written x square into cos of x plus h plus 2xh into cos of x plus h plus h square into cos of x plus h and minus f of x, which is x square into cos of x whole divided by h as h approaches 0. Let's simplify. This is x square cos of x plus h minus cos of x whole divided by h plus it's 2xh into cos of x plus h and whole divided by h. Then plus it's h square into cos of x plus h upon h. This whole and as h approaches 0. Let's evaluate. H will cancel out here, 1h will cancel out. Cos C minus cos D. This is 2 sin C plus D by 2 into sin D minus C by 2. We'll use this here. This is limit x square. It's 2 sin C plus D by 2 into sin D minus C by 2 minus h by 2 upon this is h, and plus 2x cos of x plus h and plus h into cos of x plus h as h approaches 0. Now as h approaches 0, this term will be 0. To evaluate this, this is like sin theta upon theta, divide by 2 and multiply by 2. This 2 will cancel out. We will have x square. This is sine of x plus 0, that's sine of x. And this limit will be minus 1 because of this negative sign. Plus 2x cos of x plus 0. And this is 0. We can write its x into 2 cos of x and minus its x into sine of x. This is the derivative. We have to discuss one more part today, and that is rules and formulas of differentiation. So let's write the rules first. We have 5 rules of differentiation. The first rule is that derivative of constant is 0. The second one, derivative of constant time function. This is constant outside into derivative of the function. So derivative of constant into function is constant outside into derivative of the function. The third, derivative of sum or difference of number of terms. This is sum or difference of their derivatives. That is, we can have term by term differentiation. The fourth rule, that is for product of two terms, u into v. This is called product rule. And derivative of product, this is always obtained using product rule. And what is product rule? This is first function u into derivative of second plus second function into derivative of first. Product rule. We have product rule for 3 functions, and that is first into second into derivative of third plus first into third into derivative of second, that's dv by dx. Then it's v into w into derivative of u, derivative of first. This is product rule. And the last one, this is called the quotient rule. Derivative of quotient of two functions, u by v. This is, we write denominator v square, v into derivative of u minus u into derivative of v. This is quotient rule. So next, we learn formulas. There are 16 formulas of differentiation. The first one, derivative of x raised per n is n into x raised per n minus 1. Second, derivative of e raised per x, it's e raised per x. Third is derivative of a raised per x, it's a raised per x into log of a to the base e. Now, what is different between the three formulas? This is function raised per constant, this is fixed constant e raised per x, and this is any constant a raised per x. That's why we have three different formulas. Derivative of log of x to the base e is 1 by x. Then we have derivatives of 6 trigonometric functions. Derivative of sin x is cos x. Derivative of cos of x, this is minus sin x. Derivative of tan x is it's secant square of x, and derivative of cot x, this is minus cosecant square of x. Derivative of secant of x is secant x into tan x, and for cosecant x is minus cosecant x into cot x. So we can observe that derivative of cos function, cot function and cosecant function has negative sign. So for trigonometric ratio starting with co, derivative is negative, and for others it's positive. So next we have 6 formulas for differentiation of inverse trigonometric functions. So derivative of sine inverse of x is 1 upon 1 minus x square under the root. For cos inverse it's negative of the above value. So minus 1 by the same thing. Again trigonometric ratio, inverse trigonometric ratio starting with co, and we have negative sign in the derivative. And this is for tan inverse of x. For cot it's negative of this value, minus 1 by 1 plus x square, and for secant inverse is 1 by x into root of x square minus 1. For cosecant inverse is negative of this value, minus 1 by x into root of x square minus 1. Let us learn how to use these rules and formulas to differentiate certain functions. This is the next one. Y is equal to x square minus 1 by x whole square. Let's simplify the expression. A minus b whole square is a square plus b square minus 2 a into b. This can be written x raised per minus 2 minus 2x. So we have 3 terms. We can use derivative of y. This will be derivative of this plus derivative of this plus derivative of this. Derivative of x raised per 4. This is x raised per minus 2. And derivative of this is x. So this is 4 into x cube, and this is minus 2 x raised per minus 3 minus 2 into derivative of x, which is 1. This is the answer. Next, it's always simplification first. We should simplify the given expression first, then differentiate. So this can be written y is equal to a into x square upon this is root of x, which is x raised per 1 by 2, minus b into x, this is x raised per 1 by 2, and c upon this. This will be x square, and this is x raised per 1 by 2. So 2 minus 1 by 2, this will be 3 by 2. Similarly here, minus b x raised per 1 by 2, this is minus 1 by 2. So simplification is now complete. We differentiate term by term. dy by dx, this is constant outside, derivative of x raised per 3. 3 by 2. 3 by 2 x raised per 3 by 2 minus 1, which is 1 by 2. Again, constant outside x raised per 1 by 2. This is 1 by 2 x raised per 1 by 2 minus 1. Right, minus 1 by 2. Next, c constant outside, then minus 1 by 2 x raised per minus 1 by 2 minus 1 is minus 3 by 2. So simplify, this is 3 by 2 into a x raised per 1 by 2 minus b by 2, this is x raised per 1 by 2, and this is minus c by 2 x raised per, this is minus 3 by 2. So x raised per 3 by 2 in the denominator. This can be written in simplified form, root of x, this is 2 into root of x, and this is x into root of x. Okay, coming to the next one, we are given number of terms, minus plus, this is minus, so we'll differentiate it term by term. dy by dx, this is derivative of first means derivative of this into this. This is constant and this is function. So constant outside into derivative of function. Constant outside into derivative of function. 3 constant outside into derivative of e raised per x plus its derivative of x raised per minus 1. This is 5. Derivative of log of x. We know derivative of log of x is 1 by x. So we have to learn all those formulas. 1 by x. Minus 2. Derivative of what function is? Minus cosecant square of x. So this is minus cosecant square of x. Derivative of e raised per x is e raised per x. This is like x raised per n into x, n minus 1. So this is your final answer. This is minus 1 by x square. So note that derivative of 1 by x is minus 1 by x square. Next, question number 7. Again we have number of different types of terms. We'll first of all simplify the expression. And differentiation is always after simplification. So note down that it's simplification first. So we have number of terms. This is log of a by b is log of a minus log of b. Root is raised per 1 by 2. This is 5 x raised per a minus 3 a raised per x plus x square cube root is x raised per 2 by 3. This is minus similarly 3 by 4. Log of 1 is 0. Value of log of 1 is 0. So this is minus 1 by 2 right here into log of x. These terms as it is. Now we differentiate. Simplification is complete. Now the differentiation part. Constant minus 1 by 2 outside. Derivative of log x is 1 by x. 5. Derivative of x raised per a. It's a into x raised per a minus 1. Derivative of a raised per x is a raised per x into log of a to the base c. This is 2 by 3 x raised per 2 by 3 minus 1. That's minus 1 by 3. This will be minus 3 by 4 x raised per minus 3 by 4 minus 1 is minus 7 by 4. This is the answer. The next question. How to differentiate sine square of x? So here we use the product rule. We can write sine square of x as sine of x into sine of x. So we have first function sine of x into second function sine of x, derivative first function sine x into derivative of sine x, plus second function sine x into derivative of first function, that is sine x. It's sine x, derivative of sine x is cos x, plus sine x into this is cos x. Sin x cos x plus sin x cos x is 2 sin x into cos x. This can be written using trigonometry sine of 2x. The next one, we have product of two functions. We actually multiply. To simplify the expression, this is 5x raised to power minus 3 plus 7x raised to power minus 10. Now, term by term differentiation, dy by dx, 5, derivative of this, minus 3x raised to power minus 4, 7 minus 10x raised to power minus 11. So, this is our answer. The last two questions, these are based on the quotient rule. Let us rewrite the quotient rule. Derivative of quotient of u and v. This is v square here, v into derivative of u minus u into derivative of v. Let's solve this one. This is like u, this is v. So 1 minus 3x, 3 raised to power x whole square. 1 minus 3 raised to power x into derivative of 1 plus 3 raised to power x. Then we have negative sign, minus this numerator 1 plus 3 raised to power x into derivative of 1 minus 3 raised to power x. So denominator as it is 1 minus 3 raised to power x. Derivative of this plus this, it will be derivative of 1 which is 0 plus derivative of 3 raised to power x, which is 3 raised to power x into log of 3 to the base e, minus 1 plus 3 raised to power x. This is minus 3 raised to power x into log of 3 to the base e. Minus into minus, this will be plus. We can take 3 raised to power x log of 3 common. And inside we will have 1 minus 3 raised to power x plus 1 plus 3 raised to power x upon square of this. Minus and plus, this will cancel out. So this is 2 into log of 3 to the base e into 3 raised to power x. 1 minus 3 raised to power x and whole square. The last one. Here we can use the quotient rule or we can use the product rule if we divide both the terms by sine of x. So product rule is always easier. So divide x raised to power 5, 1 by sine is cosecant of x, minus cos upon sine, this is cot of x. So derivative of y, this will be derivative of first term minus derivative of second. This is now product, so we use product rule. First function into derivative of cosecant x, which is minus cosecant x into cot x, plus cosecant x into derivative of x raised to power 5, that's 5 into x raised to power 4, and minus derivative of cot x is minus cosecant square of x. From first and second terms, taking x to the power 4 into cosecant of x common, we have 5 minus this is x into cot of x, and plus we have cosecant square of x. This is how we use the product rule, quotient rule, other rules and formulas of differentiation.